In this kinetics lab, we'll look at finding the order of a reaction. When iodate reacts with bisulfite, it yields iodine among other products. Iodine yields a deep, rich blue-purple color, which is emphasized with the starch added to our mixture. Here is a possible rate law. The rate is equal to a rate constant times the concentration of iodate raised to some power or order times the concentration of bisulfite raised to some power. In this lab, we'll find the order of iodate. We can do this by observing how the rate changes when the concentration of iodate changes, and the concentration of bisulfite remains constant. Our stock solutions of iodate and bisulfite are 0.011 molar and 0.010 molar respectively. We'll run 5 experiments called A, B, C, D, and E. And each experiment will be carried out in test tubes like these. In experiment A, we'll measure 1.0 milliliters of iodate stock solution and 4.0 milliliters of DI water for a final volume of 5.0 milliliters. Using our dilution equation from general chemistry, M1V1 is equal to M2V2, we get a new molarity of 0.0022 molar. For experiment B, we'll change the concentration by measuring 2.0 milliliters of iodate stock solution, then adding 3.0 milliliters of water for a final volume of 5.0 milliliters. Notice how the new molarity of iodate here is 0.0044 molar. Experiment C will have 3.0 milliliters of iodate stock solution and 2.0 milliliters of water. Experiment D will have 4.0 milliliters of iodate solution and 1.0 milliliters of water. And experiment E will have only 5.0 milliliters of the iodate solution. No water is added here. The concentrations for iodate in experiments C, D, and E are 0.0066, 0.0088, and 0.011 molar, respectively. For all of these experiments, the concentration of the bisulfite solution will remain constant. We'll add 1.0 milliliters of bisulfite along with 4 drops of a starch solution. Since the concentrations remain constant across the experiments, I'll ignore the concentration of the bisulfite for this video. This lab is traditionally carried out with larger volumes. Check with your lab manual and instructor for your procedures. Now, let's go to the experiment and obtain the times and subsequent rates. I have labeled each test tube with their corresponding experiments. On the left is 1.0 milliliters of the iodate stock solution mixed with 4.0 milliliters of water. On the right is 1.0 milliliters of the bisulfite solution with 4 drops of the starch solution. I'll add the contents of the iodate solution first. Then I'll prepare the stopwatch and begin the timer exactly when the bisulfite is added. I'll stir with a stirring rod for about 30 seconds, then prepare the next experiment. It is very important if you are working alone to diligently monitor the test tube. Stop the timer as soon as you see the blue-purple color. If you are working with a lab partner, one partner can monitor the test tubes while the other prepares the subsequent experiments. Another tip is to place a clean white paper or paper towel behind your samples so the color change is more evident. I'll add the appropriate amounts to the rest of the test tubes. And we'll wait for the magic to happen. Let's look at the data. I tried to stop each experiment as soon as I saw the color change. Of course, this can introduce some error. Here are the times for each experiment. Notice I converted the minutes to seconds. The next column is for the inverse of the time. Recall, the rates are proportional to 1 over time, or 1 over seconds in this case. Here are the inverses of the times. Now we can use the method of initial rates to solve for the orders. I have explained the method of initial rates in other videos. I'll summarize it here. Let's simplify this table to include only the experiments, iodate concentrations, and the rates. I'm trying to find the order or exponent. I'll set up a ratio of the rate of experiment A over the rate of experiment B and equate it to the ratio of the concentration of iodate for experiment A over the concentration of iodate for experiment B. This concentration ratio is raised to the order, m in this example. I'll insert the values. You'll see that the ratio of the rates is 0.46, and the ratio of the concentrations is 0.50 raised to the m. I can take the log of each side and obtain the log of 0.46 is equal to the log of 0.50 times m. This is one of the rules of the log function. I can simply divide both sides by the log of 0.50 to get m by itself. The order here is 1.1. This, of course, is only using 2 of my 5 sets of data. I could obtain an order using experiments B and C, or experiments C and D, or experiments D and E. You can see that there can be error if I made error in the timing of the experiment. I could, of course, obtain an order using other combinations of experiments, then take the average. You can see that the average is 1.0 to 2 significant figures, or 1 to 1 significant figure. This is the expected order with respect to iodate for this experiment. This reaction is first order with respect to iodate. You can see more of my tutorials on finding orders and rate constants in this playlist.